to look inside your work. You're taking your derivatives, you're taking your integrals, you're doing them. Now, I will say this. You're forgetting the dx at the end of your integrals. That's the biggest thing, and I'm telling you, your teacher is being really nice because your teacher is only taking off 1 point for the first one, and the rest of them, they're forgetting about that, okay? It's like missing a period at the end of a sentence, and in calculus, once you start to realize that, you'll stop forgetting it, okay? Now, the next thing is the fact that when you go look through the rest of it, there are little calculation errors, little times where maybe like the chain rule, you forgot to pull something out, or you had an extra variable that you weren't sure what exactly to do with it, but it comes down to the presentation of it, okay? It's not, as I'm looking at your work, and it's really just, if you had an extra 15 minutes on every single test that you could go back and just make sure you write your work out nicely, you probably would have gotten an extra 5 or 10 points on most of these, okay? That's the way I'm looking at it. You're looking at it like, oh my god, I got an 80%, that must mean I don't know my crap. No, that's not how this works. The issue in calculus and the issue with AP classes is the grading is a very specific style, okay? Have you noticed your teacher is kind of like the strictest grader of all your teachers that you've ever had?
Yeah, more or less.
More or less, right? Because if you go look on the way that the AP test is actually graded, if you don't show me that f prime of x is the derivative, you lose a point.
Yeah.
I will show you perfect tests, meaning that all the answers are correct, but it's a 2 out of 5 for the AP test because they just didn't get the rest of the points. I can give you all the right answers, show all my work on another page, and I'll get 0 points at the end of it, right? Or I'll get the 1 point for the right answer, but out of a 10-point question and you answer 3 of them, right, and you don't show your work for the rest of it, well, then you're going to lose out on those points. And so what it becomes is another issue here is that it's all timed. If you had all the time in the world, you wouldn't have to worry about that. You go step by step. What do I need? All right? And so that's why in this situation, I'm taking a look at this, and actually, conceptually, there's not very much missing from here. There's a couple things I want to work with you to make sure that they're the textbook ways, right? But it's like if I ask you for definitions of words that you know, you might not give me a textbook definition, right? You might not give me the textbook definition of what basketball is or what hockey is, but you can describe it to me, right? You can describe to me calculus, but you're not able to give me what the textbook, what the AP teacher and what the AP test wants exactly. And so we got to practice that part of it, okay? Now, another question I want to ask you, how do we learn? How do we absorb this information? Like, I know a lot of kids, I wish it was like, all right, I've got a program. I'm just going to plug this in my ear right now and hit a button. I'll download calculus into my brain. Now, in the Matrix, that was possible, but not in our real world. Okay, so how do you learn?
The way I learned all of this was either rote memorization or just having done the problems a bunch of times.
How did you rote memorization? Like, what exactly do you do? Is it index cards? Is it Quizlet? Is it what type of thing do you do?
For example, for all like the rules you have to remember for integration differentiation, that's just Quizlet. And the problem for me a lot of the time is that if I see that, I might not recognize it because I've only memorized
one specific problem
rule, or one specific problem that I think exemplifies the rule. Yeah, the way I've learned math is different from the way I've learned other subjects.
Okay. What do you do for other subjects?
Like, for example, for Spanish, I would just, instead of learning all the textbook grammar rules, I just listen to a lot and then practice it a lot with other people.
Okay.
So then I pick up the rules.
So let me actually present this to you, actually. One of the big issues, especially in AP Calc, is because we're so focused on the teacher getting you the information so you can actually test and test well, they forget about having to bring this into the real world. Okay, they forget about why we use calculus and why it exists in our world. All right, but we're gonna do a lot to explain all this stuff so that when you do end up having to explain these things in a conceptual manner, now you have something to fall back on. Okay, now you have a better understanding of what exactly we're doing here. Okay. So what I will do here is I'm going to go through these step by step, but what I want you to do is take these on the side and just create kind of a study sheet for yourself, okay? This is kind of the first step, but if you're going to write back on this, I'm going to ask you to grab a different colored pen and write in a different color. These are like multiple colored pens, okay? So the first thing that I need to go over with you, and this isn't even anything that's exactly on there right now, what is Calc A and what is Calc B? Why did they split it up in this way?
I cannot give you an answer to that. Oh, I suppose that makes sense.
Right? Oh my goodness. Just like, look at this. Algebra 1, Algebra 2. What do you think Algebra 3 was?
Cubic functions.
Oh my god. Okay? What was supposed to be Algebra 4? Logarithms, right? Exponents. Then we got our trig, our geometry, and then we have our precalc, which is all of this. And then we jump into calc, okay? So when you get into C, it's multi, meaning multivariable. Okay?
Okay.
That's for the future, all right? Now, this doesn't make sense to your parents. So if you have to explain to your parents right now, I don't know, they might know calculus, but if they knew calculus, if they didn't know calculus, derivatives and integrals, what's the easiest way to explain these two? What is a derivative?
So a derivative, okay, let's see. So if I'm driving on a road and
Good.
I want to see and I know where I am, that's my velocity.
Okay.
For example, if I want to find the rate at which my velocity is changing, then I have to take the derivative of the velocity to find what's it, acceleration? So the derivative is essentially the rate at which a function is changing.
Okay. Very good.
An integral.
Say that one more time. The rate at which
a function is changing.
Okay. Now I'm going to stop you right there. Because that's still a lot of words, right? The rate at which a function is changing. Now the easiest way that I would explain this to you, I'm going to ask you 3 different things. You did the first one. Which was speed, right? Speed and movement. That's going to be your first one. I'm actually going to show you all this in here. When you take a look into this little binder that I'm giving you, this little section right here is going to help you always make sure you understand what is going on. All right? So this is one of the examples, our speed. You have a position you're in. You take that position, you divide it by the amount of time that's gone by, or the distance you've gone, right? Distance 2 minus distance 1 over time 2 minus time 1. That's a slope of rise over run, right?
Yes.
Which is your velocity. So in your car, you have a place that you're at, you have your foot on the gas, and you've got a miles per hour you're going, okay? You either have the gas, which you're giving it and speeding up, or you're braking, right?
Yeah.
And so that's going to be your velocity over more time, so it's double derivative, okay? So this still is rough for a lot of people who are first still learning. And so my other examples of teaching is our instant slope, okay? And so what that means is if you're hiking along a hill, and that's my other example, if you take a look, right? Elevation or on a hill. If I'm hiking on a hill, all 7 points and x's I just put there have different slopes, right? And for us to calculate that, we can just draw a little triangle and show ourselves what's going on there, okay? And so instant slope, or meaning slope at a very specific moment in time. So what that means is in our rise over run.
It's an infinitesimally small distance.
Yeah, it's a very, very, very tiny time, second, etc., as small as we can possibly find, right? That's supposed to be an infinite number of zeros. So when you take a look at this, I have this all put out for you. That's in this page. This needs to be, right, your fundamental slope theorem needs to be something that you can repeat from memory. Are you able to do that at this point? If I asked you to write that out.
Like the limit definition?
Here. The limit as h approaches 0 of f of x plus h minus f of x over h. Does this make sense, how we get this equation?
Yeah, because you're taking it at 2 different points, which is like h, but we want,
x plus h,
yeah.
So there's a distance of h
and
over
then
there.
We look at it as h gets smaller, infinitesimally small.
Very good.
So when it gets infinitesimally small, then we have the slope at a point.
Write the equation out for me. Or just my test. If you can do that, we can move on. We don't need to go back to this anymore. I have it over here, so I'm going to just read it off of my computer. Number 1. Okay. Number 1, find the zeros, right? What is that?
Find the intercept.
Very good. So actually, you don't want to, on your test, write that. So you're just going to do this. Find the zeros, right?
Yes.
In other words, you can also say factor, right? So if you had something like, right, you could factor it into the x plus and x minus situation. Okay?
Yes.
Yeah. Pretty simple. Okay? Write that down for yourself in color because it's just something that you want to make sure that you can see, make sure that you can think about when it does show up.
Maybe red's a better color.
Yeah. Okay. Find the equation of the line tangent to f of x, right, at a and b. Well, that means line means y equals mx plus b, right? Tangent means that
that's the derivative
is our m. So we have y is equal to f prime of a x plus b. Or you could even just go get rid of that, and you can go.
Yeah. Oh yeah, that's the form that I.
Write it down. It's just the fact that, again, I'm saying again, you know that definition. You know the definition. I'm not saying you don't. But because this is the world's most strictest math class that you will ever take, okay? But I'll tell you this. There's a reason it's strict. Because if you wanted to go work at Tesla and be an engineer, you think they would let you go by and not show your work?
Yeah, probably not.
Right? Elon Musk is like, oh yeah, I trust you, and you're not going to kill anybody with that.
Yeah.
Okay?
Makes sense.
So that's all it is we use the work as accountability for each other. And another thing is teachers, when they see you got your work, you got your answer and no work, they just assume you cheated off something. Okay, that's how it works. Does this make sense?
Yes.
Now, notice as well, if we go to the next one, number 3, it's normal. So normal is just a negative reciprocal of that is now my m. Okay? Even, meaning if I plugged in a 2 here, it would be the same as what negative 2 is. Meaning everything on this side reflects across it. The easiest one you think about, you gave me an example. X squared is actually the even function that you want to think about. X to the 4th also works too. But what you just want to make sure is that anything you plug in as a positive is also the same thing as that negative. Okay? Yeah. And if it is a negative, it becomes that positive. And now the one that really tricks a lot of kids is this one, is your odd one is a double negative in here, okay? So you can even say negative here, but I just say put them both on one side. And be careful with that one, because the one that you're thinking, the x to the 3rd is 1, all right? Now what I want to be extremely careful about, because this is more of like a SAT type of question, is they'll ask you, is that even?
Yes.
Is that even?
Yes.
Is that even?
Neither of them are.
Very good. Okay? Because the moment that you take your shift and you go up or you go down, they no longer reflect across exactly where the origin is. A little hint is the fact that this should equal 0, right? Once you plug 0 in there, it usually will give you 0 because it goes through the origin. Okay? Number 6, find the interval in which it is increasing. That is right where all you're really doing is the interval where f of x is increasing just means where the slope is positive. Okay? You're thinking, I think, concavity on that point, where it was positive to negative or negative to positive. Be careful with that. Okay? And so the interval where the slope is increasing.
Okay, what's this thing?
Right? Because now you're focused on the slope, and so that one increasing. So it's rare, and I don't think they will ever ask this, but how would you do it if it were concavity increasing? You would go. Okay? I will make this quick chart for you here, actually. I love how this works is you start with your f of x, you derive, you get f prime of x, you derive, you get f double prime of x, right? So you can also say you got your distance, your velocity, your acceleration, right? Anytime you go down, you're just putting it over time one more time, right? However, the thing that I want you to think about here is when you look for, right, they're saying this is a value. This is that slope of the value. Okay? This is the slope of the slope of the value. And so earlier what they were saying is that the interval in which your value, the slope is positive, if they're saying where the slope is positive is this one. And so then also here we have this is concavity. If they say concavity is increasing, that would be being positive. Okay?
Okay.
So you can always go, I think of it as you should always have sets of 3. This, to find out information about this, you have this and this. To find out information about this, you have this and this. If you wanted information about this one, or the last, right, you go 1 and 2. You'd actually have a 4th derivative. It's just the number of x powers that you would end up having. Okay? And also just a little hint into the future, a lot of stuff in our world all ends up with sine and cosine in it, so it would never end up deriving everything out of it. It would always fluctuate. Okay? Number 8, minimum value of a function.
So you have to check where it's, well, you have to check where it's,
Concavity, right? Now, on our double derivative, here's my way of helping you memorize it. It took me a while, too. Concave up, concave down. Concave up, concave down. Concave up is a positive double derivative. Concave down is a negative double derivative, right? This is a minimum, though. You can think positive is happy or going up. Negative is down, unhappy. However, the happy is a minimum while the unhappy is a maximum. Okay? So in this situation, if they're asking you for minimum value of a function, right? You're going to do that with that.
Yeah, and then see which side
Or
is
C,
positive
C,
or negative.
C, right?
Yeah.
Go ahead and write those down. Do you guys have any questions about anything you see?